Have you ever just looked up at the night sky and felt small? I mean, the universe is just so incredibly, mind-bogglingly huge. And it begs the question, right? If we ever find another habitable planet way out there, how in the world are we supposed to get to it? Well, today, we're going to dive into some pretty wild ideas, cosmic shortcuts that might just be the answer.
Okay, I want you to get this number in your head. Ready? 94.5 billion years. Just let that sink in for a second. What on Earth could possibly take that long?
Well, that's how long it would take one of our current fastest spacecraft to get to the Andromeda Galaxy. You know, our closest galactic neighbor? It's only 2.5 million light-years away. And here's the real kicker. Even if we could magically travel at the speed of light, a feat that's supposed to be impossible, it would still take us 2.5 million years to get there. It's just staggering.
So, does that mean we're stuck? Are we just trapped here in our little corner of the Milky Way forever? It kind of feels that way, right? But believe it or not, some of the smartest people who ever lived think there might be a way out.
And the solution isn't what you might think. It's not about building a bigger engine or a faster rocket. Nope, it's about bending the rules. Literally, bending space itself. And to understand that, we have to talk about the one and only Albert Einstein.
So, Einstein completely blew everyone's minds with this idea. He said, look, space and time, they're not two different things. They're woven together into this single entity, a four-dimensional fabric he called space-time. Think of it like a massive, universe-sized trampoline net. It's not just an empty void out there. It's this active, flexible thing.
And this is where it gets really cool. You take something heavy, like a planet or a star, and you drop it onto that space-time trampoline. What happens? It creates a dent, a curve in the fabric, right? Well, according to Einstein, that curve is what we feel as gravity. It's not some mysterious force pulling us down. It's the shape of space-time itself. The heavier the object, the deeper the dent.
Now, this whole trampoline thing, it's a great way to picture it. But it's not just a cute story. This is real physics described by a set of 10 ridiculously complicated equations that Einstein gave us back in 1915. These equations are basically the operating manual for our universe, and hidden inside them are some absolutely mind-bending possibilities.
Okay, so if space-time can bend, can we, cheat? Can we use that bendiness to our advantage? That is the billion-dollar question. And one of the wildest ideas that pops right out of Einstein's math is something called a wormhole. Or, if you want to sound fancy, an Einstein-Rosen bridge.
Let's make this super simple. Grab a piece of paper in your mind. Put a dot on one end for point A and a dot on the other for point B. Obviously, the shortest way to get from A to B is to draw a straight line across the paper. But what if you didn't have to stay on the paper? What if you could just fold it in half? Now, point A and point B are practically touching. You could just poke a pencil right through them, creating a tiny tunnel, a massive shortcut.
A wormhole is literally that, but for the entire universe. The idea is that our 3D space could be folded through some higher fourth dimension, connecting two places that are millions of light years apart. You could step through a portal here and pop out in the Andromeda Galaxy. A trip that should take billions of years could, theoretically, be over in just a few minutes. It's insane. And by the way, the name wormhole is just perfect, isn't it? A physicist named John Wheeler came up with it in the 50s. He pictured a worm on an apple. Does it crawl all the way around the outside? No, it just burrows straight through the middle. It's the ultimate shortcut. Such a great visual.
All right, so this all sounds amazing. Cosmic tunnels, instant travel, sign me up. But hang on, how do you actually make one of these things? And maybe, more importantly, what's waiting for you at the other end? This is where the cosmic rabbit hole gets even deeper.
To create a warp in space-time that extreme, to literally fold the universe in half, you need a ridiculous amount of gravitational muscle. And really, there's only one thing in the cosmos we know of that's heavy enough to do it: a black hole. At the heart of a black hole is a singularity, a point of infinite density where space-time gets squeezed so hard it basically rips a hole in the universe.
Okay, so maybe a black hole is our entrance. But there's a huge problem. A black hole is a cosmic roach motel. Everything checks in, but nothing checks out. It's a one-way trip to oblivion. So if that's the door, where's the exit? It can't be another black hole, because that would just be another trap. You'd need the exact opposite.
And believe it or not, Einstein's equations have an answer for that too. It's a theoretical object called a white hole. And yeah, it's exactly what it sounds like. It's the polar opposite of a black hole.
If a black hole is the ultimate cosmic vacuum cleaner, a white hole is the cosmic fire hose, violently spitting everything out. Light can't get out of a black hole, but it can't even get into a white hole. So you'd have the perfect setup. Fall into the black hole entrance and get blasted out of the white hole exit. I know. This sounds like it's straight out of a sci-fi movie. And it's super important to take a step back and remember we are way out on the bleeding edge of theoretical physics here. So let's come back down to Earth for a second and talk about the huge gap between what the math allows and what we can actually see out there. And there are some major scientific roadblocks. For starters, a lot of physicists think white holes can't exist because they seem to break a really fundamental rule, the second law of thermodynamics. Basically, that law says the universe always gets messier over time. Disorder or entropy always increases. Black holes are great at this. They gobble things up and increase the universe's total mess. But a white hole spitting things out, that seems like it's making things neater, which is a big no-no. And then, of course, there's the biggest problem of all. We have zero, and I mean zero, observational evidence that wormholes or white holes are real. But, and this is a really big but, let's not forget that for decades, black holes were in the exact same boat. They were just a weird prediction from Einstein's math, a ghost in the machine. A lot of people thought they were just a mathematical fantasy. And then, in 2019, we took a picture of one. So you never know. Today's wild theory could absolutely be tomorrow's groundbreaking discovery. And just so you know, wormholes aren't the only crazy idea on the table for faster-than-light travel. There's another concept called the Alcubierre drive. The idea here is instead of tunneling through space-time, you just manipulate it around your ship. You'd create a little bubble of normal space and then scrunch up the space-time in front of you and stretch it out behind you. The ship inside the bubble doesn't actually move fast at all, but the bubble itself gets carried along on this wave of space-time. It's like a cosmic surfboard, and it could theoretically get you places faster than light.
So where does that leave us? With all this talk of black holes, white holes, wormholes, warp drives, is this all just fun science fiction? Just cool ideas to kick around? Or could these be the very first, very rough blueprints for humanity's future out there among the stars? Right now, we just don't know. But the math, at least, the math says it might just be possible. And that, for me, is an absolutely incredible thought.